Welcome to the third film in our Structural Members series. It takes a look at the way in which a supporting structure transfers loads. In a legal context, buildings are sometimes referred to as immovables. The word comes to us from Latin and means things that cannot be moved or removed. It refers to one of the defining features of a building. It is fixed and does not move. Statics is a branch of mechanics and, in contrast to dynamics, deals with stationary bodies. For a body to remain stationary, all of the forces and moments acting on it must be in equilibrium. This equilibrium of forces and moments is one of the fundamental principles of statics and, therefore, also of our immovable buildings. This litter bin is in danger of sinking because the sand beneath it is unable to take its weight to push against it with sufficient force. The litter bin is more stable when the dead loads, the weight of the bin, and the live loads, the litter in the bin, are distributed more evenly over a concrete slab. The loads act over a larger surface area, and the sand, which makes a poor foundation, is better able to develop the necessary counterpressure. The force resulting from these loads acts against a counterpressure exerted by the sand. The force applied by the litter bin, known as the action force, is cancelled out by the reaction force exerted by the ground. The two forces must be equal in magnitude to stop the litter bin from moving. This is known as the action-reaction principle. The sum of all the forces applied is zero. The principle operates in the same way for the horizontal forces exerted when someone stops the bin from toppling over in the wind by pushing against it. But what happens if the wind blows when no one is pushing against it? The counterpressure acts below ground, where the litter bin is securely fixed in the sand. Here, however, the action and reaction forces are not operating on the same line of action, but at an offset. What does that mean? This offset in the force couple produces a lever arm. You may remember this equation from your physics lessons. Force times lever arm equals torque. That's what's happening here. The litter bin would tip to the right were it not for the righting countermoment acting below the ground, in this case due to the self-weight of the concrete slab. As with the forces discussed above, the equilibrium principle also applies here. Moment and countermoment are of equal magnitude, the sum of all moments is zero, and the moments are in equilibrium. Now, let's introduce another term, bearing. Wherever forces are transferred from one structural member to another, the members are connected. Generally speaking, they sit one on top of the other, though it's quite possible for one structural member to be suspended below another. There are three different types of bearing. With a fixed clamp bearing, one structural member is clamped in another. You can imagine this as a hand firmly gripping a hammer in order to knock a nail into a wall. The huge crossbeam of this building is clamped into place. If it were not, it would simply tip over to one side because it's supported asymmetrically. On the left, you can see the symbol for this type of bearing. It can transfer vertical forces, horizontal forces, and moments. With a fixed pin bearing, although one structural member is fixed to another, forces are transferred by a system of articulation. Hold a pencil between two fingers. You can easily withstand pressure from above and lateral pressure against your fingers, but if force is applied to the tip parallel to your fingers, then you can no longer hold the pencil. A fixed pin bearing can transfer vertical and horizontal forces, but not moments. The same is true of the building shown here next to the corresponding bearing symbol. Then there are guided bearings. They also work thanks to a system of articulation. It's easy to roll a piece of cardboard back and forth over two cylindrical pencils. Pressure from above is absorbed, but once pressure is applied laterally, both the cardboard and pencils roll away. Bearings of this type can only transfer vertical forces. They are commonly seen under motorway bridges, but only on one side. On the other side, the bridge deck is prevented from rolling away by a fixed pin bearing. Summary: a building stands upright when the sum of all the forces and moments exerted is zero. Its structural members are connected to one another at bearings. Fixed clamp bearings transfer vertical and horizontal forces and moments. Fixed pin bearings transfer vertical and horizontal forces. Guided bearings transfer only vertical forces. Please take a look at the fourth film in our Structural Members series. In it, we will ask the question, how do external forces act within structural members?